We've all had programs crash on us before, whether it be a blue screen of death, or your Chrome tab, your Flash player stopped working, or any of these types of things. And these types of things are introduced because we have bugs in our system. When we say bug, we mean something unexpected went wrong. When we write programs, we want to be able to take into account different types of situations which may arise during the execution of our program and try to handle them in appropriate ways. A simple way to do that is using defensive programming. And there's lots of different types of defensive programming. Today we're going to talk specifically about simple data validation, which is where we're checking to see if the data coming into our program is within a permissible range, right? So for example, if we're looking for positive numbers, we want to make sure that the user isn't entering negative numbers. So simple data validation. So here's an example where we have where we're asking the user to enter a numerator, and then we're asking the user to enter a denominator. Our result is just going to be that, the numerator entered divided by the denominator entered, right? And so then we can just go ahead and print out the numerator divided by denominator is the result, right? We can run this, and when we run it, so we can just say 3 divided by 9, and it gives us back the result, right? So that functions the way we expect, right? But sometimes the user doesn't do what we expect, or the user might enter invalid data, right? So if we go ahead and we run this again, we might say that the numerator is 3, but the denominator is 0, right? And so if we do this, we're saying 3 divided by 0. And if we just ran 3 divided by 0 in Python, we get that there's an error, right? And it tells us that on line 1 of this program, so this is the only line in our program when we're running on the interactive shell is just 3 divided by 0. So in that line, we had a 0 division error where we did integer division or modulo by 0, right? So we tried to divide something by 0, and it says that we can't do that. So what we need to do is we need to make sure that our programs, when we design them, that they are robust. And what that means is that we try to take into account the situations that could arise when our program is running and make sure that we handle those situations appropriately. We want to make sure, what we need to do is we need to make sure that if that denominator coming in is equal to 0, then we don't do that division, right? So in this case, we want to print out that there's an error and say can't divide by 0. Right? And now we need to make sure that we don't run the rest of our code, right? So we can just put an else block here and stuff these inside of that else block, right? So this is one way to handle that situation, right? And we can go ahead and run this. And now if we say 3 and 0, and it tells us error, can't divide by 0, right? So it gives us back a friendly version of this error message. So the error message that Python gives us back is very helpful to us as programmers because we can actually see what happened. We had an error divided by 0. It tells us where that occurred, right? So we can narrow it down to this section of our code, and it actually tells us what file that happened in. And so this file is called validation01.py, and it occurred on line 4. So if we look in our file, it was line 4 before we edited it, right? At this point, our program no longer crashes, and that's great. That's what we want to see, right? So we can do something even a little better. We can go ahead and wrap this input call in a while loop and just continuously ask the user for a number until they enter a valid number, right? So we can go ahead and wrap this in a while loop. The while condition is going to be while we have invalid input. Alright, so while the user is giving us invalid input, we're going to continuously ask to get a new denominator, right? And so inside of our while loop, we can just go ahead and say while the denominator is equal to 0, we're going to set that invalid input flag to true, right? So while we keep getting invalid input, we're going to set invalid input to true, and then we can just go ahead and put this in its put this in, so we can unindent this so that it's outside of the while loop. In the case that a user enters a valid number, we need to go ahead and set invalid input to false, meaning that there is valid input. And at that point, it's going to set this to false. And so when it comes back up here to check this condition, it's going to be false. And it'll jump past the while loop, right? So one thing that we have to do before this is we need to go ahead and initialize our invalid input and say that our invalid input is true so that it actually asks to get the invalid input once from the user. Now let's go ahead and run this. So now we can say 9, can say 0, and you see it just keeps asking us until we give a valid entry, at which point then it continues on and executes the rest of the program. And so that's how we can do simple data validation.